Today we're going to introduce the laws of logarithms. There's three logs that we're going to be looking at: the product property, quotient property, and power property. Now, let's be honest, I am not going to make you memorize the names. I just want you to be able to use these properties. So the first property basically says that multiplication inside of a logarithm becomes addition outside of the logarithm. And I am going to put a little example next to each of these. So if I have the log base 2 of like 5x, or let me do like 10x, this will become, it's the same as, so I should probably use an equal sign, the log base 2 of 10 plus the log base 2 of x. So there are two things inside this logarithm. There's the 10 and there's the x, and those things are being multiplied together. That multiplication becomes addition between the logs, and those two things get their own logarithm. They each get their own logarithm, and they're attached using a plus sign. Well, if multiplication results in addition between the logarithms, then division inside of the logarithm is going to result in subtraction outside of the logarithm. So an example of this would be if we had log base 3 of 5 divided by y, this would become log base 3 of 5 minus log base 3 of y. The logs that you use match each other. So if it's log base 3, they're all going to be log base 3. There's two things in here. There's the 5 and there's the y, and when we separate them out, we've got log base 3 of 5, we've got log base 3 of y, and the division inside the log becomes subtraction between the logs. My shortcut, honestly, is if it's on the bottom, like this y is on the bottom, the y is on the bottom, so the log that contains that y has subtraction in front of it. The last law, we kind of touched on this in a previous section before our first half of the chapter test. Exponents inside of a logarithm move in front and become a coefficient multiplied by that logarithm. So if I have the log base 10 of x squared, that's going to become 2 times the log base 10 of x. So any exponents move in front and become a coefficient, a number multiplied in front of that logarithm. All right, let's put these together. Oh, there is a warning. Addition inside of the log is not the same as addition between the logs. There isn't a property for this. So if you see something like x plus y inside, you would just keep that as x plus y. Here's something that you might see. Log base 2 of 5 times x plus 2, that would become log base 2 of 5 plus the log base 2 of x plus 2. That x plus 2 is still going to stay together because only multiplication can be split up using addition. There's no property that we have for splitting up addition, so just leave it. If we have log base a, or log of a divided by log of b, it is simply going to be log of a divided by log of b. We cannot combine those together in any way. And notice in this last one, the cube is outside of the log. If it's log of x cubed, that becomes 3 times the log of x. But because the entire log is inside the parentheses, it is not going to give us that result. All right, let's expand these logarithms. My shortcut is basically look at how many things are inside the log. So I've got two things inside this log. I've got a 6 and I've got a t. So I know that I'm going to have log base 2 of 6 and I'm going to have log base 2 of t. And now I have to figure out what symbol to put in between them. This was multiplication inside the log, so it's addition between the logs. In this next one, this is more my speed. This is my jam. We've got two things. We've got a squared and we have b to the 5th. So I am going to do ln of a squared and ln of b to the fifth. The other thing I noticed then is that there's an exponent inside the log that needs to move out front. So it's going to be 2 times the ln of a and 5 times the ln of b. Sorry. The b was on the bottom. So whatever log has that b in it, that is going to be a minus in front of that. The a was on the top, so the a is going to be a positive log, but we don't need to put plus in front of a log. It's just kind of assumed that that's positive. But because the b was on the bottom, that log that has the b in it has to be negative. So this is our final answer for that one. This is our final answer for that one. Let's look at example 2. Example 2 is a little bit intense. We will go through example 2 together, and then I will give you another example, because we're actually going to end at the end of this example. I'll give you another one that's kind of similar to what you might see. All right, there are 4 things inside this logarithm. There's a to the 4th, d to the 6th. There's b, and there's the cube root of c. Okay, side note, the cube root of c is the same as c to the 1/3. So when we actually use this, I'm going to use c to the 1/3 and not the cube root of c. All right, so there's 4 things. That means I'm going to need ln of the first thing, ln of the second thing. Oof. I'm writing really messy. Why am I writing so messy? ln of b and ln of c to the 1/3. If you want to do symbols right now, you can, or you can wait until the end. But I see that there's a bunch of exponents here. So this exponent of 4 needs to move in front. This is going to be 4 times the ln of a, 6 times the ln of d, ln of b doesn't change, and 1/3 times the ln of c. All right. A to the 4th and d to the 6th were on the top. So those logs need to be positive. So positive in front of the first one, but we don't really need to write that. That's just assumed. The d was on the top, so it's positive. There's multiplication in between those, so that's plus. Some of you might say, well, there's multiplication here, so this should also be plus. But if we do that, we would have to do something to say that both of those need to be on the bottom. So the easiest thing to do is b was on the bottom, that log needs to be negative. The c was on the bottom, so that log needs to be negative. If you wanted to, you could have done minus and then parentheses, and then it would have been plus. But I think it's just easier. If it's on the top, connect them with plus. If they're on the bottom, those logs need to have minus in front. So this would be our final answer for expanding that log. Let's do another one. Let's do the log base 2 of 5x over y to the 3rd. Sure. There's 3 logs, or there's 3 things here. There's the 5, there's the x, and there's the y to the 3rd. A lot of people actually make this mistake and think that 5x is one thing. 5x is 2 things. There's the 5 and then there's the x. They are being multiplied together. So if I were you, I would pause and try this one on your own. We've got the log base 2 of 5. We've got the log base 2 of x. We've got the log base 2 of y to the 3rd. The exponent of 3 needs to move in front. So I've got the log base 2 of 5, the log base 2 of x, and 3 times the log base 2 of y. Now for my symbols. The 5 and the x were on the top, so those 2 logarithms need to be positive. We don't need a plus in front. I put a plus in between them. The y was on the bottom, so that logarithm needs to be negative. I put a minus in front of it. If we had also had a z squared or even just a z in there, it would also be on the bottom. So say there was a z down here, we would do minus log base 2 of z. Both the y and the z are on the bottom, so both of those logs need to be negative. But we didn't actually have that on there, so there you go. All right, you are now ready for 11.4 Part 1 book assignment.